Yes, welcome once again. This is 300 Plus Academy, where all we do is exams tutoring. We are about to move into a special theme in chemistry that's talking about calculations of chemistry, which centers around stoichiometry. And because we know we will need knowledge of certain things, that is why we are going to be looking at relative molecular mass and percentage composition. Someone will tell me, oh, this is very easy to deal with. Yes, it might be easy for you, but for some, it is not very easy. And because we believe in inclusiveness, no matter your level academically, we want to make sure that we serve your need, talking about your exam preparation. That is why we'll be looking at this. Immediately after this, we'll be looking at empirical and molecular formula. Yes, there are UTME questions on that. And then after that, we move into more concepts and Avogadro's number. We'll look at stoichiometry and stoichiometrical equivalence. And then we'll look at limiting and SS reactant. And then possibly laws of chemical combination, talking about laws of definite proportion, law of constant composition, and law of multiple proportion. So come along with me as we take a dive into calculating relative formula masses or relative molecular masses of compounds. So what do we need to be able to calculate the relative formula mass or relative molecular mass effectively? One is that we need to be able to correctly represent the formula of these molecules. We need to be able to do that. But given that some of us are not yet conversant with octet duplet rule, we don't even know how to name compounds, we don't know about radicals, we don't know about oxidation state, so it becomes difficult for us to be able to represent formula of compounds accordingly. But for now, we'll proceed, and then subsequently in the course of our sojourn in chemistry, we'll see how we deal with that. So then we have to now interpret the formula correctly based on the number of atoms present. As you can see here, question 1 says we should calculate the relative molecular mass of magnesium chloride. So when you look at it, number 1, you're looking at magnesium chloride. It means magnesium is 1, chlorine is 2. So when you look at magnesium, magnesium is given atomic mass. The mass of magnesium is an atom, so the mass of the atom magnesium is 24 plus, I am talking about chlorine here, the mass of one atom of chlorine is 35.5. So since it occurs twice, so that's going to be 35.5 times 2. This is 24 plus 71. And this is going to give us 24 plus 71. This will give us 95. Moving to the second question, we have Fe2O3. That's iron 3 oxide. This is magnesium 2 chloride. This is magnesium. This is magnesium chloride. This is iron 3 oxide. Take note of it. Iron 3 oxide. Okay. This is iron 3 oxide. So this means that iron occurs twice. That is a 56 times 2. Looking at what you have for question 2 there. And then plus oxygen. Oxygen is 16 times 3. So that is 112 plus 48. And that means 160. Okay. Moving to question 3, we have phosphorus 5 oxide P2O5. P2O5, phosphorus is 31, 31 times 2. It occurs twice, then oxygen is occurring 5 times plus 16 times 5. 16 times 5 is 80, and 31 times 2, that is 62. 62 plus 80, that's going to give us 142. Now, imagine that in this phosphorus 5 oxide, I am told to look for the percentage composition. I am told to look for the percentage composition of phosphorus in here. Then what that means, recall, I want to calculate relative molecular masses, and then I want to look at percentage composition. Now, if I'm looking for the percentage of phosphorus in phosphorus 5 oxide, that is going to be, what is the mass of the phosphorus itself? The total phosphorus here is 31 times 2, that is 62, out of the total, which is 142. Then I'll percentage that So if I compute this, that is going to give me, if I compute this, that is going to give me 43.66%, and I'll be correct. The fourth question talks about sulfuric acid, tetraozo sulfate 6 acid. Hydrogen is 1, so that is 1 times 2. Sulfur is 32, and then oxygen is 16 times 4. This is 2 plus 32 plus 64, and this will give me 98. So imagine I am told to look for the percentage of sulfur in H2SO4. That means I am looking for the percentage composition of sulfur in H2SO4, and that is going to mean, what is sulfur? Sulfur in here is 32 divided by the total, which is 98. So sulfur is 32 out of 98. Then I percentage that, I should of course get my answer. So that should give me 32.7% approximately. So nothing to really stress over. Look at the fifth question. We have copper triazonitrate 5. Copper triazonitrate 5. When you look at copper, the oxidation state of copper here is +2. And triazonitrate, that's NO3, is a radical with 1 charge. So I'll need 2 of these to balance with the +2 charge of the copper, and that is why I have this twice. So copper triazonitrate 5. Of course, copper in that question is 64 plus I have nitrate. Nitrogen here is 14, and then oxygen is 16. 16 times 3, that is plus 16 times 3. Now all brackets times 2 for what I have here. So that's going to give me 64 plus, into bracket, 14 plus 48, all multiplied by 2. 64 plus 14 plus 14 plus 48, that's going to give me, okay, 58, 62 times 2. 62 times 2, that's going to give me 124. 64 plus 124, that's going to give me 188. That's 188. So that just ends that way. So imagine I'm being told to look for the percentage composition of nitrogen in copper triazonitrate 5. If I'm told to look for the percentage of nitrogen in copper triazonitrate 5, so it means I have to now identify my copper here. This is nitrogen, it is 14, and it is occurring twice. So that is 14 times 2. My nitrogen is 1 inside this bracket, but I have a 2 subscript outside. So if you multiply it, that's going to be, percentage of nitrogen is going to be 28. Nitrogen here is 28 divided by 188 times 100. So that is how I am going to get my percentage composition for nitrogen. Okay. And that is 14.89%. Still on this particular example, imagine I'm being told to calculate percentage composition of oxygen in copper triazonitrate 5. It means I have to identify my oxygen in here. Now oxygen in here is occurring 3 times. Then I have the 2 outside. That's 2 times 3 is 6. It means oxygen is happening 6 times, and oxygen here is 16. So that is 16 times 6. So percentage composition of oxygen is going to be 16 times 6. That is 96 out of 188 times 100. That is how I'm going to get the percentage composition of oxygen. And that is 51.9%. 9.06%. So now moving on, this is another question 6, aluminum tetraoxosulfate 6. If I am to calculate the formula mass or relative molecular mass, RMM, of aluminum sulfate. So now aluminum, as you can see there, has an atomic mass of 27. So this is 27 times 2 plus, of course, here I have sulfur. Sulfur is 32 plus. And then here I have 16 times 4, that's 64, all multiplied by 2. 27 times 2, that's 54, plus 32 plus 64, that's going to be 96 times 2. 96 times 2, that is going to be 192 plus 54. 192 plus 54, that is going to be 246. Yes, 246. So that is the relative molecular mass of aluminum sulfate, 246. Now, let's imagine we were told to calculate percentage. Let's assume we were told to calculate percentage composition of aluminium in aluminium sulfate. So moving on, we are looking at question 6. We were told to calculate the relative molecular mass of aluminium tetraoxosulfate 6. Aluminium tetraoxosulfate 6. And in here, that means relative molecular mass, or you can as well call it formula mass of aluminium tetraoxosulfate. Of course, this is 27 times 2 plus sulfur here is 32. Oxygen is 16. 16 times 4, that is 64. Everything here multiplied by 3 because we have a subscript here. So 27 times 2 is 54 plus 32 plus 64, that is 96. 96 times 3. So 96 times 3 is going to give us 288 plus 54. So 288 plus 54 is going to give us 342. Yes, 342. So moving on from that, imagine we were told to calculate percentage composition of aluminium in aluminium sulfate. So at that point, it means percentage of aluminium is going to be, aluminium in itself here is 27 times 2, and that is 54. 54 out of 342. Times 100. So that is how we calculate the percentage composition of aluminum here. 54 divided by 342. And that's going to give us 15.79%. 15.79%. 15.79% No more, no less. Moving on to another question, question 7, talking about ammonium thiazocarbonate 4, NH4 thiazocarbonate. Okay, you recall that carbonate, ammonium in itself is univalent, having a charge of +1, and thiazocarbonate 4 is divalent, having a charge of -2. So you can see the positive charge must balance the negative charge. That is why we need this twice, so that it balances the negative charge of thiazocarbonate. The reason why the formula is like this. So looking at calculating the relative molecular mass of this here, nitrogen is actually nitrogen is 14. So I have this in bracket. Nitrogen is 14, hydrogen is 1. 1 times 4, 4, all multiplied by 2, plus this is carbonate. Carbon here is 12. Oxygen is 16 times 3. 16 times 3. 16 times 3. So this is 48. And this is 12. 14 plus 4, that's 18. 18 times 2, that is 36. 36 plus 12, that's 48. 48 plus 48, that is 96. And that is our answer for that. Yes, like I said at the beginning, if this is not something you know in chemistry before, there is no point shying away from it. Just be humble enough to learn it, so that when we move into much deeper stuff in chemistry, talking about stoichiometry, it is going to come easy for you. But jumping this and without knowing it, that is where the real problem is. Now let's look at question 8. Question 8 talks about iron sulfate heptahydrate. Yes, this is FeSO4.7H2O, and this is iron 2 tetraozosulfate 6. 7 is hepta, just like heptagon, heptahydrate. In other words, when we have water, this is what we call water of crystallization. What it does is that it is responsible for the shape of the salt, for the crystalline shape of the salt. And salts that usually contain water of crystallization usually cannot withstand much heat. Don't worry, when we get to separation techniques, we get to learn more about this. So moving on, we were told to calculate the molecular mass of this, or the formula mass. So how do we go about this? The relative molecular mass here is going to be iron is 56, as you can see, 56, plus sulfur is 32, oxygen is 16. So 16 times 4 is going to give us 64. Then you have a dotted, of course, that means plus. In this case, water, when you calculate water, water is H2O. H2O is usually 18. H2O is 18 because 1 times 2, hydrogen is 1 times 2, plus oxygen, which is 16, that's 2 plus 16, that gives us 18. So what we have here instead is 7 times 18, because our water is 18. So 56 plus 32 plus 64. So computing this together, that's going to give us 278. So imagine here, I am told to calculate the percentage composition of water in iron 2 tetraozosulfate 6 heptahydrate. I have seen a JAMB question looking like this. So what that means is that when you look at the water of crystallization here, that is actually 7 times 18, and that's 126. So percentage composition of water here is going to be 126 out of a total of 278 times 100. That is how you get the percentage of your water of crystallization, and that is 45.32%. 45.32%. That is the percentage of water here. So Moving on to question 9, we have magnesium sulfate heptahydrate, otherwise known as Epsom salt. Of course, in here, we were told to calculate the relative molecular mass or the formula mass. So magnesium is 24. Magnesium here is 24. Sulfur is 32. Oxygen is 16. 16 times 4, that is 64. Plus water is 18. So 7 times 18. Of course, 24 plus 32 plus 64. That is 120 plus. So this is going to give us 246. So imagine we're told to calculate the percentage of magnesium, the percentage composition of magnesium here. So that is going to be, what is my magnesium? It is only 1. So in this case, that is going to be 24 out of 246 times 100. And that is going to give us, so that is 9.76%. So, moving on to the last question, we have sodium thiazocarbonate 4 decahydrate. Yes, sodium thiazocarbonate 4 decahydrate. Of course, in this case, we were told to calculate the relative molecular mass or the formula mass. It simply means the same thing. So, sodium in this case is 23. It happens twice, so that's 23 times 2. Carbon happens once, that's 12. Oxygen happens thrice, that is 16 times 3. Plus water is 18, happening 10 times, so that is 10 times 18. Of course, what I have here is 46 plus 12 plus 48. 48 plus 12, that's 60, 106 plus 180. That is going to give me 286. So that is the relative molecular mass of sodium thiazocarbonate 4 decahydrate. If I'm told to look for the percentage composition of water in sodium thiazocarbonate 4 decahydrate, what I'm going to do is, my water here is 180 out of 286 times 100. So that is 62.9%. And that way, that is how we look for relative molecular mass and we calculate percentage composition. So not to worry. It is always better to start from the simple to the complex. That way you leave no stone unturned. So moving on to summarize things quickly as far as percentage composition and relative molecular mass is concerned, let's take questions that are UTME related. So you see that, look, it is not just about claiming it's a simple topic. JAM or UTME is about accumulation of points, how many points you're able to garner. So look at the question 2003, question 3. You can also see that on your screen. It states, what is the percentage by mass of oxygen in aluminum sulfate dihydrate? So what this means is that I'm to look for the percentage by mass of oxygen. So very quickly, the first thing I need to do is to calculate the relative molecular mass of the hydrated compound. In this case, my aluminum is happening twice, so that is 27 times 2. Okay, sulfur, then plus I have sulfur, which is 32. Then oxygen is 16. 16 times 4, that is 64. Everything here multiplied by 3 plus 2. Water is H2O. H2O is 18. Water is 18. So when I try to take this together, this is 54 plus 32 plus 64. That is 96. 96 times 3. So that gives us 96 times 3 plus 36. 2 times 18 is 36. So that I have 54 plus 96 times 3 is going to give me 288 plus 36. So that gives us 378. Now it's time to calculate the percentage by mass of oxygen. To calculate the percentage by mass of oxygen, you have to look at the formula as a whole and try to identify what is oxygen here. When you look at here, oxygen is 4 times here, then 3. So 4 times 3. Oxygen is occurring 4 times, then times 3. So oxygen here is 12 times. And then in water, the oxygen is occurring twice. You can see oxygen occurring twice. So that is oxygen is happening twice here. So that cumulatively, oxygen is happening 14 times. And that is going to mean 16 times 14, 224. So when we say percentage by mass of oxygen, so when we say percentage by mass of oxygen, that's going to give us 224 divided by 378 times 100. That's 59 points. Looking at all of the options we had there, yeah, 59.25%. And in questions like this, you have to just be careful so that you don't do the wrong thing. Look at what someone else, this is the correct thing to do. This is the correct thing to do. Look at what someone else is going to do. And I'm going to solve this the wrong way now. And you will still see the option. This here is option D, as you can see on your screen. Now look at it. Like it happens to most students, what they do is that they are very likely to use the oxygen here, omitting the oxygen in the water of crystallization. What you basically have is Al2SO4 3.2H2O. If you forget about the oxygen here and you use the oxygen here, that means 4 times 3, oxygen is happening 12 times. So 16 times 12. If you say 16 times 12, 16 times 12, recall that oxygen is 16. So since it's happening 12 times here, 16 times 12, that will give you 192. So the percentage composition of oxygen is 192 divided by 378 times 100. If you do this, that will give you 50.79. This will give you 50.79%. And that is also in that this figure is actually also in the option. That is as option C. So you will see that in this question, they are just waiting on you to commit that error using only the oxygen here, forgetting about the oxygen in the water of crystallization. And once you do that, you will see that option seated comfy, option C, whereas the correct option is 59.25 because we were told to calculate the percentage by mass of oxygen. So which means all of the oxygen that appears in this formula is what you have to look for the percentage. That is 2003 question 3. So moving on, as you see displaying on your screen is another UTME question, 2010 question 3. It states that we should calculate the percentage by mass of nitrogen in calcium triazonitrate 5. So you can see that in this case, the formula was not written. So what you must first of all do here is, if you're not able to write the correct formula, then there's going to be problem. So, and for you to put out the right formula, you must know about your radicals. You must know about the oxidation state of your various elements, at least the first 20 elements. You must know about octet duplet rule, because these are not things we memorize. No, they are things we know, that we understand. But let's quickly look at it. So how do I put out my formula? Whenever you talk about triazonitrate 5, triazonitrate talks about NO3 minus. So this is having a negative charge of 1. And when you talk about calcium, calcium is element number 20. If you want to distribute electron, that is 2882. For calcium to attain octet electronic configuration, it needs to get rid of the 2 electrons here. Now this one only needs 1 electron to get balanced. So the best thing is for me to increase this so that if I have another one of this, one electron to this, and then one electron to this. That way, it will be balanced. My calcium here will become Ca2 plus, and of course, if I have NO3 minus happening twice, that just balances. So that is why I am going to write my formula here as calcium triazonitrate 5. This is the correct formula. Imagine this is saying calcium sulfate. Of course, calcium is 2 plus. My sulfate is SO4 2 minus. This just balances. So how am I going to put this down? I'll put this down this way, CaSO4. And it goes on and on like that. So in this case, calcium triazonitrate 5, I was told to look for the percentage by mass of nitrogen. First and foremost, I need to get the formula mass or the relative molecular mass of calcium triazonitrate 5. Calcium here is 40. Calcium here is 40 plus nitrogen here is 14. Oxygen here is 16. 16 times 3, that is 48. Everything here multiplied by 2. 14 plus 48, that is going to give you 62. 62 times 2, and then I have my 40 here. 62 times 2, that is 124. 124 plus 40, that is 164. So since I am looking for percentage of nitrogen in this, nitrogen is happening twice. So percentage of nitrogen here is, my nitrogen 14. Nitrogen is 14, is happening twice. So 14 times 2, that is 28 out of a possible 164 times 100. So my answer here is 17.07%. 17.07%. If you look at the options, we have option B. So that is approximately 17.1%, and that is correct. So this is something for those who don't know. Take note of this so that you begin to garner your point as far as UTME is concerned. Okay, moving on, and last but not the least, we have 2014 question 3. They said, what is the percentage of sulfur in sulfur 4 oxide? So you can see this is another question where you're expected to correctly write the formula. And when you say sulfur 4 oxide, this is sulfur 4 oxide SO2. When you say SO3, this is sulfur 6 oxide. So we're looking for the percentage of sulfur in sulfur 4 oxide. Talking sulfur 4 oxide, sulfur 4 oxide is actually 64. If we have to calculate, sulfur is 32. Oxygen is 16. 16 times 2. 16 times 2. So that is 32 plus 32. That is 64. So when you say percentage of sulfur in sulfur 4 oxide, that is sulfur is actually 32 out of a total of 64 times 100. So 32 divided by 64 times 100 is going to give you 50%. And when you look at the options that you have there, that is rightly